Hey everyone, welcome to another video in my series of making a Pokemon style game. And in this video, we are going to bring in our throw animation for our trainer, and we're going to have our trainer throw a Pokeball around. Let's get to it. So to kick things off, I'm going to do something slightly different because I want to make sure that we start this project with an animated Pokeball. And I've already recorded the video for animating the Pokeball that I downloaded of the internet some time ago. So let's just do a quick flashback to that video and I'll see you after that's over. And with that, it's time to animate a Pokeball now because we want it to be able to open and close to capture Pokemons. Maybe even do a little shake. So if you didn't download a Pokeball that's already pre-rigged and that you can open and close, you'll find one in the file section and you can just use that one. Alright, so I'm in Blender and I've imported my Pokeball from 3D.com, or the one that you can download from the Canvas site that comes with this course. And we have to zoom in a little bit because it's not too big. And what I find is that the creator has set the X rotation to 90, so I want to make sure that everything is set to 0 before we get started. So to do that, Object, Apply, All Transforms. And that should set all the rotations to scale to 1 and all the rotations to 0 and location to 0, 0, the way we like it. Lovely. So with that out of the way, we can go into animation. Now, this is just a preview. When you click on animation, it's still the same software, but we can zoom in this window here and in that window there as well. We won't use this one as much and most other stuff will happen down here, but this is kind of just like a little preview window that they have. So I'm going to move a little bit to the side because we're not going to be using that one. And yeah, I'm going to move this up though. You don't have to do that yourself, but it's just so that I have this keyboard overlay here that I can't see, but you should be able to see it. But stuff is going to be happening in here. I don't want to cover it up. So there we go. Anything else that I would like to edit? Yeah, for now, I'm going to uncheck this thing here because this will only show selected, which for beginners could lead to a lot of mistakes because you're not seeing animations that are actually there when you're not selecting the right bone for the animation. So we're going to take care of that. And I think everything else is good for us to get started on our animation. So first things first, let's start with the length of our animation. So we can click here on our dope sheet. A dope sheet is where all the keyframes of our animation will be. So the keyframes are the key points in which we're going to determine this is where we want a certain bone to be in the animation, and everything that's not that doesn't have a keyframe will be interpolated. I've already explained that in a previous video, I believe. But I'm gonna click on dope sheet up here on the icon and then select timeline first so that we can set the length of our timeline. And I'm moving this around with my keyboard a little bit because I want to scale this the way I like it. And I want to set it to, I could have done it down here as well. Actually, I forgot about that. But I just want to set it to 20 keyframes, which at 30 frames per second is going to be a little bit under a second, which is a good length. Actually, if you want to set the frame rate for your animations, that happens down here in the output window. Not that we need that for anything right now. So anyways, I can set this back to dope sheet because we are going to mess with a couple of our animations. Because we want to open the Pokeball, we want to close the Pokeball, and we want to wiggle our Pokeball around. So thankfully, we already have a rig in place, so we don't need to make it. We can select it. And if you select an object, different stuff will become available to you. So if we just select the Pokeball, we can, it's a mesh, so we can sculpt it, we can do vertex painting and so forth. However, if we're selecting the armature, none of that's available anymore, but there is a pose mode available. So that allows us to select individual bones, like so. It has a blue Fresnel. There's 3 bones here, actually, in the rig that this Pokeball has. And you can select those bones as well by going up here into pose, and then you'll see all of them in relation to each other. And there's a down. So when I select this one, that's at the bottom. There's an up. That's, I think, the one in the back. And then if you just click on body, that's the one up here. So that's how it's rigged. We don't really need that. We're going to be able to select them right here. But yeah, this looks nice. So let's make an animation. So to make multiple animations, we want to go into our action editor because an action is going to be an animation really. And I'm going to make a new one. I'm going to call this one open because it's going to be for opening our Pokeball. As you can see here, summary has appeared all of a sudden. And that summary is really going to be the root of all the animation work that we're going to be doing in all our keyframes. So let's make a keyframe. So I'm going to select this thing in the back here, because don't do this, but I'm just going to show you. If I press RX, I will rotate over the X-axis with that bone. So as you can see, that will allow us to open and close. So that's what we want to do, but we want to set that. So first off, Control Z, and let's keep it in the default position, because we're going to make a default keyframe, because we want to start here and then we want to open it up by frame 20. So to do that, what we want to do is we want to press the I key. And before you do that, make sure that you're in this window, because you're going to get different options when you're down here with your cursor. So pressing the I key, and I want to make keyframes for rotation. Clicking on that, and what that will do is it will make that dot appear, and you'll see that those are here. Now, this should say quaternion. If it doesn't say quaternion, you want to click on this little thing here for the bone, and you want to set the mode to quaternion. So if you set this to Euler, and you do the same thing, you don't have to do this, I'm just going to demonstrate it. Press I, rotation. It'll make a track with Euler rotations. But Euler rotations are prone to gimbal lock, as I've explained in a different video. So you want to actually manipulate the quaternions instead. So that's an important thing. Now, we can manipulate them down here, or we can manipulate them in the window. I'll demonstrate both. For this one, I'll do it in the window itself. But first, we have our we have our first keyframes down here. We just want the ball to look like that in frame 1. And in frame 20, we want it to open. So let's make some keyframes there. Click on rotation. Oops, I forgot to set it back to quaternion. So from Euler, not Euler, let's go back and rotation. There you go. And now we have keyframes. Now, when we're moving, nothing's happening yet because we didn't do anything for it to interpolate. But what I wanted to point out is if we're at a keyframe, the color here will turn to yellow, and otherwise it will be green because we're interpolating. Okay. You'll also notice that this thing here, this little diamond, that means that there is a keyframe there. So if we move, it'll be blank, and if we move onto a keyframe, it will get colored in. So anyways, just some helpful stuff. So we're working on the open action right now, and actually we want to do the last one. So there are multiple ways to do this. One way is pressing R and then pressing X like we already did. Then you can move it wherever you like. Like if you're like, I want it to be like that, that looks perfect, great. But if you want it a little bit more precise, you can manage this here, or down here, whenever you make an action in Blender, it will actually leave whatever you did in the lower left corner so you can manipulate it. So let me Control Z for a second and do it again. So I'm going to do R, X, rotate over to X. Oh, whoops. Again, R, X, because I inadvertently already moved it. Move in here, just putting it anywhere, maybe like in a really bad position would be, oh, jeez. Yeah, when I'm talking, really bad position, right? But what I can do now is I can go here, open that up, and it'll be an angle of 30.5. So what I would want is when I think minus 90 would be great. Yep, so that will be opened up. So great. So that opens up our Pokéball exactly. And now you can see the bones in there as well, which is pretty cute. Now, one thing to keep in mind though is we haven't really made many changes yet, because if I move this around now, it'll just revert. So why? Oh, that's annoying. No problem at all. Let's do it again. R, X, move it anywhere you like, go to rotate, and do minus 90. Now, a shortcut that you can do is you can do on your keyboard RX minus 90, and it'll do the same thing. Actually, let me demonstrate that for you. So RX minus 90, I can just type and it'll do the same thing. I have to press enter then, and then this menu will pop up. So there's multiple ways to do those transformations, but to actually have it register here, what you need to do is you need to either you do I and you do insert keyframe again. That's one way of doing it. Or you need to make this blank and make it full again. So double click it basically to save the keyframes. So there are many ways to do it, but just keep that in mind. And once you've done that, you'll see that the green parts are going to interpolate now. So great, we've made our Pokéball open. We've animated something. It's called open. Now to save this, I mean, you can do Control S on your keyboard and that will save the file, but it won't actually save the animation, or rather the data block that comes with the animation. I'm not going to explain data blocks right now. I'll give you a video with a further explanation on how that works in the further reading that comes with this class. But to make sure that your data blocks are saved, you need to make a fake user. You need to click on the little shield icon here. So just make sure you click on that, because otherwise this file will disappear. Also, I kind of want this file to have a different name. I want it to be called _open because the alphabetical order will determine which animation is going to go first in Unity. And if you want this one to be first, to make sure, because if we're going to have a close, the C comes before an O, so then the close will be first, and we don't want that. So an underscore will prevent that. And that's our first animation. You can save your Blender file here, and this looks good. This looks good. If you uncheck this here, you'll see there are no other animations in there. So that's great, because let me show you how this works now. If I select a different bone like this one here, while this is on, no animations are visible. And if I click the bone, then the animations become visible. However, if I uncheck this, even if I have another bone, you'll see that on up, which is the name of this bone, in the armature you can see that there are quaternions on there. Even if I'm selecting this bone, we can still see that there's animations going on there in this action. So that's super helpful. All right, so yeah, first things first, we've got that out of the way. Let's move on to the close animation. So for our close animation, we're going to make a new action. So when we click here, you can see that we have the open action. And when we click on this, it'll actually duplicate, I think, but it's for creating a new action, and it'll be called open 001. So we don't want it to be called that. We want it to be called close. So again, you'll see that here. And we want this to get its own user as well for saving, but we'll do that in a bit, the little shield. But yeah, so we've got our Pokéball like this, and I think it just does it cover? Yeah, it just copies everything over. I think that's kind of how that works. So when we press play, oh, it's actually already doing stuff in. Oh no, there's the reverse play, and there's the forward play. I pressed the wrong button, and it looked like everything already happened for me. But what I can do now is, since I have a copy, I can easily just put it in reverse. Now in Unity, what you could do is you could run the open in reverse to do a close. But I like to just have a separate animation for it. So we're going to make it a separate one. And all we have to do really is select the keyframes, drag them, and switch them around. There we go. And we can save that as well. Do it like that. So this is only when we actually save it that it saves this animation as well, because otherwise it's not going to be saving it. It makes the yellow go away for some reason. I don't know why. But yeah, it's a quirky Blender thing that I'm not familiar with myself. But if we go to open now, you'll see that it opens. If we go to close now, you'll see that the animation is a closing one. Okay. So yeah, we got two of them in place. We can press Ctrl S to save. And let's do the last one, which is going to be our wiggle. So for our wiggle, I want to start from this thing here again. So yeah, there is a reference now. So now there's a number 2 because there's a reference from close to open. Again, I'm not going to explain how Blender does its file system. If you click here on Blender file, you'll also see that there are 2 actions now. Because in Blender, a lot of stuff is being saved. So this is where your actions are. And actually, if you've never seen this, like this is where your textures will be, or actually your images that are saved with the file. And this is all the different kind of brushes. Your rig is right here. So this is how you can look into your Blender file. I'll go back to view layer. And yeah, let's make another one. Let's go make a copy of this, a new one. And this one is going to be our wiggle. So we're going to rename it to wiggle. And now we have a wiggle in there as well, which we want to save, and I'm going to do that at the end. And we already have a bunch of keyframes in here that we don't really need, although the first one is helpful. So I'm just going to go to the end. I'm going to select these keyframes. So just these, not those. Right click and then delete keyframes. And that will remove them, and then we have an empty one. And again, if we go to open, everything is still there because that's a different action, right? So cool. We have everything in here, and what we want to do is want to make some keyframes at the end that are the same. So we can just go here, click, select the. Oh wait, yeah, no, I want to delete them all because I want my wiggle to use a different bone. Or can we use the same bone for this? Let's see. If I press X over the Y-axis, no, R over the Y-axis. Yeah, so that's not moving everything. So we want to use a different bone for that. And it's actually going to be this bone here that allows us to do that. So what we're going to do is we need to get rid of all these keyframes here. So we can just select the other ones as well, delete keyframes, and that will delete all our keyframes. However, it will also make it new because there's no connection anymore to the previous file that we had. It's a quirky thing. If you understand the file system, it will make sense. But so we're going to move from that bone to the bone in the middle now. I'm going to save it for a second. And again, if we go to open, everything is still going to be there. And we're going to be animating our up bone. So if I go back to wiggle now, I'm going to animate the bone in the middle, which inadvertently has seemed to disappear. Okay, that's kind of weird. Where did my bone go? Control Z. All right. Well, I guess, is it just, I mean, it's still going to exist because it's there. So I'm just going to select it here, and I'm going to press I, and I'm going to click on rotation. And now we have body here as our rotation. But yeah, I don't know why all of a sudden the Fresnel became invisible. Oh, right there is right. Yeah, it's just a rendering thing, or did I inadvertently move it down a little bit? I don't know, but make sure you have it selected and it should work fine for you. And I'm going to move to number 20, and we're going to make a keyframe there as well for rotation. And again, no animation just yet, but we're going to go to 5, make keyframes there too on rotation. And so what we would want right now is a rotation over the, let's see, I'm going to press R, and I think it is the Y-axis. Yeah. So I want to have a rotation over the Y on this bone, and that looks good for a wiggle, right? Something like that. So I'm going to press escape to not make it happen, because I want to use this thing here now to show you how that will work. So if I'm going to manipulate the quaternions, I've told you this in the previous video, not a good idea because that's complicated. So what we want to do is want to go into Euler, right? And the type of Euler, actually, it depends on the order in which your axes are going to be to avoid gimbal lock, really, as you're animating. So honestly, you can pick just any one of them that you like. We'll figure it out as we go along. And let's mess with the rotation here. Oh, yeah, because we're doing X, Y, Z. The Y, we actually want to manipulate the Z right now because that's how our axes are rotating. So we can use a Z, and there we go. So I want to set this to, like, is 25 a good number? I think 25 is pretty solid. And that puts our Pokéball there. Now the same thing is, if we're moving this around, it will reset because we didn't save any keyframes there. Even though there are keyframes, you can see that they're not saved there. However, if we were to save them right now, if we, click on this thingy here, we are creating a Euler track. And that's not what we want. We want a quaternion track because otherwise we'll run into gimbal lock. So we have to go back to quaternion. And there are keyframes here, but this rotation isn't saved. So what we want to do is, double click them basically. And that will reset the keyframes. And now our animation will apply. Okay, that's pretty cool. We can do the same on, I think, like, let's do 15. And we want to do the same thing there. So let's just go to X, Y, Z, set this thing to minus 25 this time because we're rotating the other direction, and set it back to quaternions, and then create some keyframes. And that should do that. And when we're looking at it now, we get a good animation. Now, usually I like to make my keyframes before I start editing them. This worked as well. Now, I let a little extra space in there because you'll see why. If we run this animation, there's a little bit of an issue. If you press play. Oh, I'm in reverse. See how there's a little stutter? That is because frame 1 and frame 20 are the same frame. So it'll put that same, that's the same position 2 times in a row. We don't want that. So what we want to do is we're going to go to frame 19, and we want to, again, create keyframes. Now, I'm not going to do it up here now. I'm going to do it down here. And you'll see that it asks you what channels do you want keyframes for. So like, let's only do the selected channels. There we go. And then we got keyframes that should work. And we are, see how it's not 1 and 0 and everything. So we can just select these. We can just delete those keyframes. We won't need them. And then down here, we can set our end to 19 frames instead of 20 frames. And that should look fine. All right, so I'm going to save that here, and that will take care of wiggle over the body. And you'll see that open is still, oh, yeah, if we're going to do that, we need to adjust this here as well. So we can just select those frames, move them up. All right, and we can go to close. And we can move those up as well. I mean, another way that we could have done it, was just push them back, but this is how my brain works. But yeah, with all that in mind, we should have our animation set. Just make sure that you save it by clicking on this thing here. And, oh, one thing, yeah, so since our open was at the end, or since we went through close, we had everything, because we don't have keyframes on the up bone right now. So we have to be careful. Like, you want to make sure that as you are exporting is that everything is in the space that where you want it to be, and that the starting point is correct. Because, yeah, I mean, a better way to do it was maybe to put some keyframes in there for the other bone as well, so that everything is just put and everything's kind of hard-coded in the animation. But I think this should do it. While we're in wiggle, everything looks good at the start. When we're in close, it is open at the start. And when we're in open, it is close at the start. So this is looking good to me. So only thing that I want to do before we move on then would be to go set our frame rate, because I've actually tried exporting at this point and I ran into an issue, and you need to have it set at 29.97 frames per second, because otherwise Unity does some weird importing stuff that we don't want. But that should pretty much be it. And yeah, I think at this point we are ready to do our little export. So we can just do export FBX. Great. This is really big. But so one thing, if you have messed with your export settings and you want to revert them to default, I'm going to make this window a little bit smaller. You want to divert them to default, you can go up here, restore operator defaults, which can be helpful. I don't think that's the case for me, but if you've made some settings changes. And I'm just going to call this one Pokéball Animated. All right. And then in here, all we want to do is make adjustments for Unity. So the recommendations that you apply: scaling's FBX all, apply transform on, space transform off. And the forward needs to be, so it's asking, what do you want the forward in the FBX to see, the forward vector? So for us, that is usually, I think it's minus on the Y forward. But if I made a mistake, or it might be positive on the Y forward, but our Y is going to be forward in Blender. In Unity, Z is going to be forward. So Unity will see what's the forward and turn it into Z. Or up is C up, so we don't have to change that. And then bake animation is on, so this all looks good. And we can export this. And then we can go to Unity. So what I am going to do in this video is we're not going to write our own physics code. Like we haven't really implemented a lot of physics, but we have not been using the built-in physics engine to animate our trainer or to have our trainer walk around. We are going to do that for the Pokéball, so that as part of this tutorial series, you get some idea how you can set up physics in Unity. And to do that, you want to drag your Pokéball into the scene. I like to rename it to just Pokéball. Not that it's super relevant, honestly, because we're gonna spawn them later on anyways. But we can add a component, and we want to have a rigid body. Now you can look that in the manual if you like. Rigid bodies allow certain game objects to interact with the physics engine of Unity. And you can set some physics values, like for instance, what's the mass of a Pokéball? I don't know, like probably about 500 grams, half a kilo. I have no idea what that is in ounces, honestly. I think it's like 8 maybe. Anyways, it's not, I wouldn't expect it to be super heavy. I think 500 grams is already quite a bit. And if you use gravity on, you can do that. You can keep it on. That means that the object will start using gravity and will start falling down, which is great. But since it doesn't have a collider yet, there's nothing to calculate the collision with the ground. So it will just go straight through the mesh if you would press the play button. You're welcome to try it out if you like. I'm not going to waste my time with it because I already know that's going to happen. So I'm going to add a collider instead. And with that collider, the collider will make sure that our mesh collides with the terrain that we have. The only thing that we want different here is our radius needs to be a little bit smaller, like maybe 0.07. Not really seeing the collider yet. I like to set it so that the collider is visible. There you go. So it's slightly visible in the engine. That should look good enough. All right. So when we press play now, hopefully everything will work and the Pokéball will just fall on the floor and roll about, as you can see. Isn't that super cool? So, that would be a little bit of work to just put a whole bunch of math in to calculate that ourselves. But Unity has got us covered, as it does so often. So yeah, with that, I think we're almost ready to start messing about with our animation controller and write some code to hook everything up to each other. The only thing I'm going to do before that is I'm going to make sure that in our prefabs folder, we have a prefab for the Pokéball as well now. So you can just go in here to make your prefab, click and drag, drop it in there. And we're not going to use a variant. So the difference between an original prefab and a variant is basically, you can kind of look at it as a parent class and a child class. So your original prefab would be the parent. And if you want to make varieties, variants of that specific prefab, like say you want to add a different texture to it or something, but retain all the other properties, you could make a variant. We don't need that. We're just going to use this as our original prefab, and we can just call it Pokéball. And from now on, whenever we're using a Pokéball in game, we're going to just use this one, which is great. All right. So yeah, with that, I think we've got everything set up to go to the next step, which means that we are going to have to set our code and our animation controller. So let's start. I got the animation controller right here. So I'm going to go into animations for the trainer, and I'm going to make this look like this again. And we're going to bring out the throw animation. Now, this is not going to loop, so that's good. That's off. And the way I want to set this up really is I would like us to be able to throw from any of the states except from jumping, because that will require, we'll be up in the air while we're jumping, so that is never going to look good with the throw animation that I have. But from the other states, we can go straight into throw. So I'm going to set it up so that I get 3 animation states, for, or at least arrows from 3 animation states going in there. And I'm going to fast forward real quickly here while I do that. And that brings me here. So what we have now is we have the throw animation right here, and we have transitions. Right click, make transition, in case you were wondering how that worked. From idle, from slow run, and from walking into the throw. So that's how I want to set everything up, and there's nothing from jumping because we're in the air there. I don't want to be able to go there. So we're also going to set up a Boolean again, is throwing. Now, there's other things that you can do. I've already discussed in the other video. You could work with float and integers. I don't think that would be great here. A trigger could kind of work, but well, a trigger is more something that you want to do if you want to pre-queue an animation to come up at a later point while you're still finishing up an earlier animation. Check out the Unity documentation for more information on that. It'll get pretty abstract unless I show you how that works. But a Boolean is going to work just fine for this as well. So in our code, we want to set up and create that Boolean. So I think what we can do is private bool, and we're going to call it just throwing is fine here, I guess. Throwing and false. And that's going to be the Boolean that we're going to be using. And that looks fine. So from here, what I want to do is I want to stop all movement on the ground pretty much as we are throwing. So that if we are walking or we're running and we press the left mouse button to throw, I want us to stop walking or running, because otherwise I'm going to need more animations and blend those together. And that is really beyond the scope of this tutorial. Like, you can do that on your own if you want to figure that out. But for students that are not really interested in more advanced animation, I think that will take us a little bit too far out. Now I'm looking here, what would be a good spot to mess with that? So I think what I want to do is, let me see, everything is kind of all over the place here, but we've got our vector movement here, and then we're checking the magnitude for the walking. I'm going to grab this bit, and I'm going to move that down here, just to keep things a little bit clearer, because this is just checking for an animation. And I think, all right, so here we're calculating our movement, and then we're calculating the shift thing, trying to figure out where things are going. So I think after the running, this would be a good spot for me. I mean, this is personal preference where things make logical sense to you, but for me, I think this would be good to put some code in to stop moving when throwing. So let's see here. So let's start with the same code we've been using for a while now. So if input get button down, because we don't need to use the get key down, because we know that there is a fire option I'm not going to go back into the project settings. I'm sure you've seen this in one of the previous videos. So when we press fire, and actually we want to make sure we're grounded as well. I don't want it to work while we're jumping. So if we're firing, we're pressing fire and we're grounded. Then we're going to set throwing to true. And while we're at it, we can also do the player animator and set that bool to the bool I think was called is throwing with a capital, throwing like so. Oops, accidentally pressed tab there. And we're going to set that to true as well. So yeah. Now we're not stopping moving just yet. How I'm going to do that again? Well, we probably, so this would just be throw. It's not stop moving, and then here apply movement, and then we can check for throwing in there. So if we're not throwing, all right, what am I going to be doing? If we're not throwing, oh yeah, but these are spread out now. That makes things kind of interesting because now I got two of these here. Yeah, my code is getting kind of hard to oversee since I'm not really paying, I'm just trying to teach you guys how to write some simple code rather than really nice and clean code. But yeah, let's just drop that in here. If we're not throwing, we can press the shift button or we can just run regularly. And if we're not throwing, it's fine to run these animations as well. So I don't think that's necessarily an issue. Yeah, and this is still just a movement vector. That's fine. So, I mean, at this point, we could just get away from the throwing one as well. But the reason why I'm using a throwing variable is because I want the animation to turn this back to false. So once the animation is done, it turns back to false, and then we can enable everything again. So that's why I want this Boolean in there, and we'll look at that in a bit. So okay, I grabbed this code from here. So if throwing, we're doing all that kind of stuff, and I think the jumping should go in here as well then. Because if we're not throwing, we can jump, but if we are throwing, I don't want us to be able to jump. So where did I put the gravity in the jumping? Right here. So let's just grab this entire thing. That should be fine. Just put it right behind here. All right. So I'm just going to call this regular movement and running. And that's gravity and jumping. And this is just like if we're moving, we can apply the walking animation. Now, if we are, we could move that over to there as well, and we don't really have to worry about. Oh no, we still need to check the magnitude because we could be standing still. So I think I'm just going to keep this here. It's pretty simple code, even though it's not well organized. Famous last words, right? So, all right, we're rotating along the camera. I think that one is still fine to have out there because, if we're throwing, I want us to be able to move the camera. And yeah. And the reason we're not using an else statement here is so that I can turn it on and off really easily. And that it's not just tied to the button because we want the animation to be able to mess with it as well. I hope that makes sense, but I'm going to show it in, I'm just going to demonstrate that in just a second, I think. So, yeah, maybe what I should do now first is, well, it's going to be hard to demonstrate, but we can have a quick look at what this does when we run. The only problem is I can't click because if I click with my mouse to hide the mouse, the throwing is going to start and nothing should work anymore. Oh, all right, that's already not good. There seems to be some issues here. So let's resolve those because I am not clicking, but the stuff is happening for sure. That is peculiar. All right, let's have a look at that. And oh yeah, of course, the reason for that is because by default, exit times are on. So when exit time is on, that means that this arrow will go into effect if that animation ends. So when trainer idle ends, it'll immediately go to the throw state. So that's why we're seeing that. And we're going to have exit times on from everywhere. Well, actually, we can leave the exit times on from the throw because we want that to happen with our throw. As soon as our throw animation is done, we want to go back to any other kind of state, but we don't want to have walking or running go immediately into the throw state. So exit times for anything going into throw needs to be off because otherwise you're going to see what we just saw. And let's see if our code is working now. Hopefully it does. So we're walking, everything looking normal. Oh, the animations seem to be working correctly too. Running, jumping, jumping. Yeah, I mean, I'm not seeing anything weird now. We're not getting into throw, but as soon as I click my left mouse button, let's see here. I might have messed with my code a little bit off screen. So yeah, to figure out what was going on, I commented this. So let's uncomment this again. But yeah, I just did that myself while I was testing. So let's get back to the actual video or the actual Unity project. And going in here, as soon as you click the mouse, this is what's going to happen. So that's good. So let's test it one more time. So as long as you don't click, everything should be working the way it was. But then we click and our character gets stopped in space. Jump is not available. You can't even get into a running state. So you're stuck in there. All right, so that's great. That's what I wanted. So, okay. And this is still pretty manageable as code. So, yeah. With that in mind, what we want to do now is we want to set things up so that as soon as isThrowing gets activated, we go right there. And this is going to be very similar to the jumping thing. This has priority over everything. So if isThrowing is true, set it up. If isThrowing is true, set that up. And if isThrowing is true, all right. So that will do that. And then we will get the exit time and we'll go back into that stuff. However, we should still be stuck. This will just show us the animation, but we're not going to set the Boolean. So as soon as I click, we see the throw animation and it'll go from the throw animation somewhere else. But as you can tell, isThrowing is never turning off. So we need to find a way to turn that off. And to turn that off, we actually want to do that at the end of the animation, right? So how do you do that? Well, you can double click. Sorry, I need to drag this over from my other screen for a second. So here we are. You double click an animation and you'll see what is called the dope sheet with all the keyframes for an animation from within Unity. Now, this is not something you want to edit. You can already see how cumbersome it is to just drag in from a different screen, but I'm actually going to have to put it away for a second again. I'm going to, just to show you guys, grab the mesh here and put the trainer in here. And this should be my throw animation, right? Yeah. So you can see the trainer throw here. And you can see the frames that come with it. And in the dope sheet, you'll see those frames as well. Now, right now, there are 2 points that are going to be of interest to us. The first one is at the very end. That's easy. We know where that is. That's right here. However, we also want to know the frame, because we're going to throw a Pokéball in a minute, where we get up here and how far that is. So this would be a good point to release a Pokéball when we would be throwing. So that's around frame 23. As you can see, if I click these 3 dots here, I can set it to seconds or I can set it to frames. So that's how you can figure out where your animation is at in the dope sheet so that you can run code at any given point of the dope sheet. So how do you run that kind of code? How does that work? Well, there's some options here. The first one is add a keyframe, like all the other keyframes here. We don't need that. Well, there's one to filter, and then you have one to add events. Events, that sounds great, right? Yes, so we're gonna go to the end of the animation, and we're gonna add an event. And that event will open up this animation event thing, and we can just call a function there, a function that doesn't even exist yet. We're gonna call it throw ended. And oh, sorry, force a habit. Don't put the parentheses behind it, just the name. And you can pass some variables or even an object if you wanted it along with the animation. We don't need that because we have only one player character and it's never going to conflict with anything. But that is what you could do if you want to, I don't know, identify which character launched a certain animation and so forth. We're also going to add another one in here because I already explained it and it will save us a little bit of time. I think around frame 23, 24, whichever you prefer. I'm going to pick 24. I thought 23 was a little bit Kobe, right? So, well, 23 would be Jordan. But, and the function that we're going to use here, I don't know, what am I going to call it? Release Pokéball. Yeah. I use a really big cursor to make it easier for you to see where I'm at, but release Pokéball. So what will happen is during this animation, when Unity plays this animation now, whenever it hits frame 24, it's going to call an event function, release Pokéball. So if we have a public method anywhere that has release Pokéball as its name, it's going to call that method. Same at the end, it's going to do not release Pokéball, but it's going to do throw ended. Okay, so that's how you can run code at certain points in your animation, which can be really helpful for all sorts of things, depending on what you need. Like I've even used it to put audio on animations when I worked on my game Brutal in Unity and Unreal. So yeah. So with all that, what we can do now is we can add some methods, and we already know which methods we want. The name of our first method is going to be throw ended. So public void, because it's not returning anything. Release, throw ended. I'm getting ahead of myself here. And throw ended doesn't have any arguments, and we're gonna use this to set throwing back to false. So that all this stuff up here that we can't run because it only runs when throwing is false and throwing goes through as soon as we click the mouse, that can run again. So that'd be great. And while we're at it, let's make sure that our animator is doing what we want our animator to do. So let's set the bool, and the name is throwing. I really wish that writer would just do that for us. And we're no longer going to be throwing. We're it's ended. Now, this code is probably redundant since we have the exit time thing. So we don't really need to write this code. So I'm just gonna do this and comment it out in case it's not working well and we come back here, I'll remember that, okay, I probably just want to call this. But we don't really need to call this, I think, because we have on all the exit arrows, we have HasExitTime. So as soon as this animation's over, it will automatically go there. Now, this means that players can't escape this animation, which is what I want. Like, this is the gameplay that I want because I want to keep things simple and I want to show how everything works in Unity. If you want to make your game better, maybe you do want an exit animation, but then you probably also want to blend it into different variations of walking, running, and so forth, which will make this a lot bigger. You can group these things together if you want, but for the sake of this tutorial, I think this is more than complicated enough. So I think this would be pretty nice. This should get us going. So let's see what happens. When I click now, I get one animation, I get another animation, and I just go straight in and out again because its throwing is still on. Okay, so I was absolutely wrong. We do need to set this Boolean. So there you go. But, I hope you get why I made that mistake, because it's the exit time will do the animation. It's just since the Boolean hasn't been set yet, we just jump back in. So, okay, I've learned my lesson, and I hope there was a lesson in here for you as you're watching this as well. But now if I click it, the Boolean should go to false. Yep. And everything works correctly. So as we're running now through it, as soon as I press, it'll stop the run. So clicking the mouse stops the run. Doesn't matter if we're walking, stops us walking. If we're jumping, however, nothing happens until we get to the ground. So yeah, we have our animation set up for the throw, and I think this looks fine. So the next step then is going to be adding that Pokéball. And to do that, we can create a new method. Now, before I get into that though, I quickly want to point out that this is not colored in purple magenta because Writer can find this function or this method inside of that animation. So it's not an issue, it's not a bug, it's not really a feature either, but just something to be aware of that sometimes when it's grayed out, if it's a function or it's an event that's going to be called somewhere where Writer can't see it. So what we're going to do is we're going to write a new method, and this one is going to be to spawn a Pokéball to a bone. There we go. So spawn Pokéball to bone. And how does it work to spawn a Pokéball to a bone? Well, what we want to do is we want to grab a copy of our prefab Pokéball right here, and we want to attach that to the hand. And I've already opened this up, so in case you haven't, you can click on it and then you'll see Mixamo Rig, and you can keep on going until you find the right-hand thumb. And that's where we want to put our Pokeball. And as you can see, what will happen then is it will go in here, and as the animation plays, the ball will just stay in the same spot and move along with the animation. Now, keep in mind though, you want to set the position of that ball in here in your prefab in 0, 0, 0, 0. And another thing that we want to do is we want to make sure that we disable gravity and our sphere collider at this point as we are doing this. Because if gravity and the sphere collider are on, let me show you what happens. So we get weird stuff and the ball will just get disconnected from the player. So we don't want that. So we are going to use gravity to throw later on, but for now we don't need it. And we also don't want that sphere collider because that collider is going to collide with the collider of the player, right? So we don't want any of that. And then we can safely delete the Pokeball here as well. Just make sure that in the prefab down here, sphere collider is turned off and gravity is turned off as well. Otherwise, you might run into some pretty interesting issues, okay? All right. So, and yeah, keep the right-hand thumb available from the rig because we're going to need it later. So first things first, what kind of code do you use to spawn a ball? Well, we're going to use the code, the function, the method called instantiate from the GameObject. And instantiate has a bunch of overloads. You can Control P through them. And the one that we want is, it's the third one. So it's going to take an object, which is a prefab in this case. So the Pokeball prefab will be our object original. Then it's going to ask for transform parent. So we're going to grab the transform of that right hand bone to put in there. And then finally, the Boolean instantiate world space. That's a Boolean that when it is, I believe, false, it will make sure that the coordinates from the prefab are used in relation to the bone rather than to the world itself. And we want that. We want the Pokeball to be attached to the coordinates of the bone rather than the world itself, because that's going to be very far away from that bone, right? We want it to be in the hand of the trainer. So that's what we need. We need the prefab, we need the transform of the bone, and then we can just drop a Boolean in there. So let's serialize a little bit. So here we go. We're going to do Pokeball prefab. That's the first one that I want. And then the second one we want is we want to transform Pokeball bone transform. There you go. So what kind of privates are we going to want? We want game object for this one, and we're going to call it Pokeball BF. There we go. And then for this one, it's going to not be an animator anymore. It's going to be a transform. And we're just going to give it the wonderful name Pokeball bone. There we go. Yeah. And another thing that I like to do is whenever I instantiate something, whenever I make multiple copies, generate more objects, I like to keep track of them for as long as I need. So I'm going to make a variable to just keep track of the Pokeball as they are attached to the player. So it's easy to find them. I don't know if we'll end up using this, but this is going to be a private one. Private game object, I guess. Attached Pokeball. Or actually, it might not be attached throughout. So let's call it instantiated Pokeball. There we go. Let's copy paste that. So down here then, in our new function, spawn Pokeball the bone, we're gonna get instantiated Pokeball, and it's gonna be equal to the result of instantiate, and our first one is going to be Pokeball BF. Then Pokeball bone, which is a transform. And then finally that Boolean, and I think we want it set to false. I'm not gonna look up the documentation because this video is getting pretty long. If it doesn't work, we'll just work with it as we get there. And here, I think this would be a good spot. As soon as we throw, we wanna spawn the Pokeball the bone. And yeah, so let's see if that actually works when we get to our Unity editor. All right. So let's press play, and hopefully with a little bit of luck, because I went pretty quickly, yeah, that's what that'll do. Okay. Now, if you're seeing any errors with this, right, if you messed anything of the code up, you can make sure that your Pokeball, well, for one, you can press escape and you can pause, and you can double click the icon to find wherever your Pokeball is at. Okay, so I mean, they're all at the same spot. But if you double click this, it should jump straight towards it. You might have to zoom in a little bit, but it'll select it. Let's double click on the trainer again. Make sure that your rigid body is not using gravity and that the spear collider is disabled by unchecking this. And as long as you do that and you have this value set to false, because if you set it to true, it will be, the coordinates will map with the world rather than the bone. So if you set this to false, everything should work the way it is working for me here. All right. So with that, we can add another method, and now we're going to add a method that is going to use that animation, if you remember, because this video is getting pretty long. If I double click, no, not slow run, but double click on throw, there was an animation here, release Pokéball. Let's make a method for that. So, and this one, I think it needs to be public because we're working with it from outside of this particular script, and we're going to do release Pokéball. That was what it was called, if I'm not mistaken. And this is all going to be just pretty straightforward, just manipulating that ball, adding gravity to it, using the gravity from Unity. So first off, let's make sure there is a ball. So if it's instantiated Pokéball, let's put a parenthesis there. If that is not null, so if there is a instantiated Pokéball, then we can do a couple of things. First off, let's detach it. I just keep writing attached Pokéball, but it's actually instantiated Pokéball. Let's detach it from the parent. So let's detach it from that bone. And to do that, you just have to grab the transform, get the parent of it. So this is where in Unity's code, the instantiated Pokéball has a transform, and that transform is attached to the parent, attached to that bone. If we set that to null, there's no more connection there. So this will release the ball from the bone, right? So then next up, and we're gonna have to use instantiated Pokéball a lot, so I'm just gonna copy paste. Next, we're gonna get a component of our Pokéball, a component of the type sphere collider. Remember that collider that we set up, right? And that has a whole bunch of properties that you might remember from the Unity editor, including enabled. And we're gonna now enable it because we're going out in physics and we want that collider to work so that the ball can actually land on the ground. Next up, we want to get another component. What component could this possibly be? Pray tell. Well, it is going to be the rigid body. If you guess rigid body, you guess correctly, because we want to turn our gravity back on for this object. So we're going to set that to true as well. Lovely, lovely, lovely. So this is already going to do a whole bunch of wonderful things for us. So let's see where this brings us. And let's press play on this. And then we can figure out what else we want to do to make this work well for us in game. All right, let's press play. So this should release the ball from our hand on that frame where we trigger that event. Oh yes, it works. All right, now it's not that our trainer is a little bit, lacks a little bit of upper body strength or something. It just seems to be that we're not really doing much with the ball. So what we want to do is, when that event is triggered, we want to add some force, some physics, and just use force instead of the movement function that we have been using so far to make that ball fly out a little bit forward. So how are we going to do that? Well, first off, we want to know where our camera is pointing. So let's grab the transform for our main camera. Let's call it camera transform again. And that's going to be equal to main camera.transform. And this should be straightforward code. We've already done this before. If you remember, to rotate towards the, here we had camera transform right here, and we declared it up here. Now you have to declare it again because we're no longer in void update. So this no longer applies. So we're basically copying that bit of code down here, which is fine. But it's grayed out because it's not being used yet, but we'll do that in a second. Now, what do we want to do? So first off, we want to figure out what vector is going to tell us where to throw, right? And so that's going to be the vector, the forward vector of the camera, with maybe a little bit of extra power. So what we can do is let's create a vector 3. Right? Vector 3, we're going to call it throw vector. And throw vector is going to be equal to the camera transform. Oops. Transform, right? And we're going to get the unit vector pointing forward so that it's forward to where we're going. And we're going to add a throw strength to it. We could set up a variable for this type of stuff. Yeah, I forgot to do that. Maybe let's set up a variable. So for throwing, maybe, what do we do with speed? Just publics? All right, let's just do a public float, throw strength, something like that. And I don't know. If running is 5, maybe 4. I mean, so this is not going to be a similar value. You can't really compare it. But we want to multiply by 4 that unit vector. So a speed of 4, I think, should be fine because we don't want to be a super hard toss either. So yeah, where's my method? I forgot. Here we go. So we're going to just do that times throw strength. There we go. Just making sure that I didn't forget to put an F there. Okay. All right. So that's going to be our throw vector. So this is going to point in the direction of the camera, multiplied by a number to give it a little bit of oomph. And then we are going to use instantiated Pokéball again, because now we want to apply some physics to it. So what we want to do first is we want to get our component again, the rigid body, because physics is going to be applied to the rigid body component. And we're going to use a function called add force. And if you don't know about this function, you can just find it in here, or method rather. I say method and function interchangeably a lot because I'm self-taught in programming. But so the first thing we need our force, and our force is going to be defined by this throw vector. So that makes a lot of sense. And then the force mode, you have a couple of options. There's an enumerator there. You can do acceleration, you can just do straight up force, you can do impulse, velocity change. Usually for a throw, an impulse I feel works the best. But you can mess around with the other options if you like. And once that happens, I kind of want to get rid of my instantiated Pokéball. At this point, my Pokéball is free to roam and do whatever it wants. We might make another one later on, but at this point, our instantiated Pokéball might as well be null, so that the next one that gets released can use all this cool stuff again. So yeah, this would be nice, and this is still grayed out for the same reason as why this one's grayed out. I already explained that. So let's see if this works and if we want to make some changes to it or not. And that's going to be the end of the video because this is getting really lengthy. So, okay, I like that. Yeah. I like that. So I don't know what you guys feel about. I think that one went through the terrain or something, weirdly enough. But like most of them seem to be rolling just fine. I'm not gonna bother if there's like a minor collision issue or something going on. Let's roll in the other direction. Yeah, but I mean, for me, this plays pretty well. But I see 2 issues. One, those Pokeballs are just rolling ridiculously far. So yeah, we need to do some friction or something. So that's one thing. And I also feel like when I'm throwing really close, I like the throw, but when we're getting back, it's because it's throwing towards the forward vector of the camera, so it's a little bit too much in the center than what I would like. So let's fix that. So let's first make a vector 3 so we can have a little bit of an adjustment. Vector, or maybe we should just call it throw adjustment. So that it'll go a little bit more upwards, and we can make a new vector 3 for that. And I don't know, like maybe definitely something on the y-axis. I mean, it shouldn't be a lot because we're dealing with a unit vector that's coming in. That's not going to be more than 1. So something like this, like 0.5. That might give it a little bit more of a throw. So let's see if that works. Well, that's not going to work because I'm not applying it anywhere yet. So what I want to do is so you need to add the vectors, obviously. So add plus throw adjustment, and then times throw strength. So that will get the forward vector and add a little bit to the y. So that it will be a little bit more upwards. And I probably forgot something. Oh yeah, double not set to float, so I forgot to put the F there, because then it will be, the literal will be interpreted as a double by Unity. It's just a C# thing, really. Don't forget your Fs, because otherwise your floats will become doubles. All right, so let's see what happens now. Yeah, that's way better. I like this. Yep. So now they throw it really, really nicely, no matter where my camera's at. Yeah, it's a little bit higher when you get closer, but we're not going to do an adjustment for the distance the camera is from the player. I don't care about that. This looks good enough. So that's nice. Final thing, how do we stop the ball from rolling? I think I just mentioned friction earlier, but that's actually not how friction works. Friction works really well in game engines if you have, for instance, a cube that you're sliding down a surface. Friction will stop that cube. We have a ball that's rolling, so friction is not going to do anything. Now, if you wanted to implement friction, what you could do is you could go to your terrain up here, actually, and add a physics material. Because if you, just for the sake of showing you this, if you do create physics material, you'll see that you can set dynamic and static friction and bounciness. For the sake of not making this video too long, I'm just going to delete it, but you can try it out if you like. Change those values, apply it to our terrain up here by dragging it in here. You'll see it's not going to stop the ball. However, to stop the ball, what we need is damping, so that the air resistance will stop it from rolling so much. And that's pretty easy to do. We can just go into our prefab, go to our Pokéball, and set our drag and angular drag. Like, I don't know. Let's just put it to 1. See what that does. I don't even want to think about this. And I'm just going to put it to 1. Like, I find a lot of the times when you're balancing things like this, making a game, just try big numbers. Oh, yeah, I'm fine with this for now. This looks great. This is what I would expect. This is close enough. Let's see. I mean, that's on a little bit of a hill. This is just perfect. This is just perfect. All right. Yeah, we can toss Pokeballs around now. Awesome. How cool is this? This makes the game so much more fun already. And even the animation. Huh. Looks like he's kind of keeping a ball in hand. I don't know why. I don't know how that happened. But that's something for a later video maybe to look into. Let's unplay and let's press play again. Is there just a ball by default now, or is it just... Yeah, it's a weird thing in the code, I guess, but... Oh no, the ball leaves. Yeah, I don't know why that ball got stuck there. That was funny. It might be if you... Yeah, so three ones in, it's getting stuck. Maybe, yeah, it's when I click... Okay, so I need a little bit of code to fix that as well, I guess. Well, and it shouldn't be too hard to do that, because all we really need to do is pretty much copy this thing over here and check that there is no ball. So if the ball is null... Oh, jeez. Yep, let's log this up. Here we go. So if the ball is null, then we can do an instantiation. So because we don't want to throw more than one Pokeball at the same time. So let's get back to the game. And I think that should do it. Let's find out. All right. Click. Pokeball. Yeah, so now I'm just going to click like a madman, but yeah, it's just... Yeah. So as soon as the ball is out of our hands, we can spawn a new one, which is kind of interesting because it makes it look like, you know, we'll spawn it even while we're at the end of the animation. But yeah. All right. So yeah, I think this is working fine. And with that, we have reached the end of another video. I hope you enjoyed watching it as much as I enjoyed making it. I'll see you in the next one. Bye-bye.